What's up, dog?
What is going on, man? Unit 9, Modern Physics coming
Let's
at you.
go!
This is Ryan.
This is Caleb. We're
Modern
ready.
Physics, baby.
Let's
We're
go.
ready.
Modern physics.
Alright, so first off, we got the formulas.
We got formulas. Number one most important thing in this unit is formulas. That's what y'all gotta learn that. Alright. First, we got quantized energy, baby. Let's go.
Check it out. We got E equals HF, PC, or HC over wavelength E. Energy. Then we got H, Planck's constant, 6.26 times 10 to the negative 34th.
Hey, man, you remember that? Let's go.
Yeah.
Woo!
And we got F, you already know, frequency measured in hertz. Then we got P, momentum of the photon, times C.
3 times 10 to the 8th, speed of light.
I had a kid
All
right
right,
on.
hey, you gotta get this one right here.
Oh, HC over wavelength, can't forget it. You already know. Planck's constant times speed of light over wavelength.
Let's go. All right. Enough of that. We don't need this anymore.
Yeah.
Throw that out there.
Goodbye.
All
Number 2.
right. Hold on. We're gonna go through. We're gonna save the photoelectric effect for the last.
Actually, yeah. Well,
All right.
that's kind of a big one, you know?
We're gonna go. How do you pronounce this?
de Broglie wavelength.
De Broglie. Here we go.
We got wavelength, obviously, equals H, you already know Planck's constant, 6.26 and 10 to the negative 34th, over P, momentum.
Momentum.
You already know.
This is,
De Broglie wavelength. On to
Now
the
that
next
we're
one.
done with this, on to the next. Energy mass equivalence.
You can thank your boy Albert Einstein for this one. E equals mc squared. Energy equals mass times the speed of light squared. AKA the energy mass equivalence.
These little mountain triangle looking things, these are deltas.
Oh yeah.
Change in energy.
Change in energy equals change in mass times speed of light squared. You
Alright,
already know. And you know what?
That's
Never
it.
forget Albert Einstein.
He's the man.
Yeah.
Alright.
He's a man you don't know, bro.
Hey! Hold on.
Hold on. Technical difficulties.
It's just rough. Oh. We are.
So this is just the grind,
Like,
the physics
we're
life,
good.
you know?
This is
Alright.
physics.
Photoelectric
Second
effect.
Photoelectric effect.
Big one. Big.
The most-
hey, huge.
Huge. Hey, it happens, alright?
We got K max equals H, already know Planck's constant, times frequency, measured in hertz, as you already know, times phi, which is the work function in joules.
Minus.
Oh, did I say times?
Case of time.
Oh,
it's
you
already,
already-
hey, it happens, bro.
It's minus. It's minus phi, which is the work function in joules.
Let's go. Okay. Hi, Mom.
I'm Miss Wilkins.
We're filming a video.
Huh?
We're filming a video.
Oh, that's awesome.
Yeah. Can we order pizza?
No.
Oh.
Dang it. All right. Okay, we're good. All right, Mom, you need to dismiss, please.
Yeah,
All right.
photoelectric effect, goodbye.
That's it.
Alright, so now we got what y'all have all been waiting. Wait, hold on. I gotta put the Lucky Cowboy hat back on. Might be.
Yeah, what are you doing, bro?
As I was saying, we have what you've all been waiting for. The Unit 9 free response problem. Yes, indeed. Here we go. I'm just going to read it out to y'all. I'm just going to read it out. Story time. Gather around the campfire. So, in a photoelectric experiment, light is incident on a metal surface. Electrons are ejected from the surface, producing a current in a circuit. A reverse potential is applied in the circuit and adjusted until the current drops to zero. That potential at which the current drops to zero is called the stopping potential. The data obtained for a range of frequencies are graphed below. As you can see by the graph, stopping potential is on the y-axis, frequency on the x-axis. Yes, there it is. And then
A.
part A. Oh, we already have written all over, so you can ignore this. We're going to get to this later in the video. But
Yeah, don't worry about that. It's all
those are
good.
the answers. Those are the
Snapchat, bro.
Then we got, for a frequency of light that has a stopping potential of 3 volts, what is the maximum kinetic energy of the ejected photoelectrons? Once again, we will get to part A, part B, part C, and part D in the rest of the video. For now, those are just the answers. Ignore those. We'll tell you how to do them later. Part B, from the graph and the value of the electron charge, 1.6 times 10 to the negative 19th. Determine an experimental value for Planck's constant, or H. Yes, we will use the graph, and we will find part B later. Part C, from the graph, determine the work function for the metal.
Easy.
Yeah,
Work
easy.
function.
You guys are going to get this down pat. I'm telling
Guaranteed 100.
you. Guaranteed. Guaranteed. All right, and part D, let's finish it off. On the axes below, draw the expected graph for a different metal surface with a threshold frequency of 6.0 times 10 to the 14th. And there you go, guys. That is your free response. Unit 9 problem.
Let's go.
Let's go. We're about to dive in. We're about to dive in. Woo!
All right, Caleb's gonna explain A.
Part A. So we have for frequency of light that has a stopping potential of 3 volts. What is the maximum kinetic energy of the ejected photoelectrons? So here's what we're gonna do. We are gonna use another formula for Kmax, which is electron volts times stopping potential. So we have K max equals E V electron volts times S. So EV is a constant, 1.602 times 10 to the negative 19th. So we're going to get that out of the way first, and we're going to go K max equals 1.602 times 10 to the negative 19th.
We're gonna need that.
Yeah, we're going to need this calculator sec, times S. Now, what's S, you ask? Let's go to the graph real quick. They give it to us. Stopping potential, 3 volts. Let's just circle that right there. We got S3. So we're going to go to the next step. K max equals 1.602 times 10 to the negative 19th times, actually, we'll go parentheses, 3. Boom.
You can also get 3 from the
Yeah,
problem
3
right there.
yeah, gives you 3.
3
Now,
volts. Okay.
next up, we're going to use the calculator right here, handy dandy. We're going to go 1.602 second E negative 19 times 3. And we get our answer 4.806 times 10 to the negative 19th. And that, kids, is part A. You just got some free points. AP just hit you up some free points right there, just so you know. Boom.
What's the units?
Oh, my B. Joules. Joules is the units.
And that is how you do A. Great job, man.
Hey, thanks, man. Thanks.
Fist bump it.
Oh, yeah. Fist bump. So now we're on to part B, ladies and gentlemen. Let's dive right into it. So we already know that EVS is a Kmax formula. And as we saw in the beginning of the video, we have the other Kmax formula. We got HF minus phi. So here's what we're going to do. The question says, from the graph and the value of the electron charge, which is 1.6 times 10 to the negative 19th, determine an experimental value for Planck's constant. So here's how we're going to do this. We are going to set EVS equal to HF, so Planck's constant times frequency, minus
Work
phi, the work function. So then we're going to try and get into a y equals mx plus b. So what we're going to do is we're going to divide EV.
No, just E.
Oh, yeah.
Same thing, though.
Same
It's
thing.
the same thing. But
So then we got boom, boom. Now, here we got S equals H over E times F minus phi over E. So, now that we got that, we're going to go to the graph here real quick. We're going to try and set up some
Alright,
rise over run. So we got the slope. So M, or the slope, equals HE.
and so
H
rise
over
over
E.
run.
So slope, rise over run. Rise over run equals, let's go to the graph real quick. So we got rise. Let's
pick some points real quick. Okay, so
yeah, so we're gonna go,
this one-
it intersects right there. Oh, intersects at the bottom. So rose 2 went over 5. So here,
times 10 to the negative 14.
Yes,
or
as you can
14
see.
because frequency is hertz.
okay, so now we're gonna go rise, obviously 2 as we saw from the graph, over 5 times 10 to the 14th equals, so now that we know that H over E, we know what E is. What is it, guys? Oh, yeah, that's right. 1.602 times 10 to the negative 19th. So,
Dang, you're on fire, bro.
woo! And
Cool
then
down.
H over 1.602 times 10 to the negative 19th.
And what this is just a proportion of these solve for H.
Exactly. So
Cross
you're gonna
multiply?
go. We're gonna cross multiply real quick. We're turning back the clock, ladies and gentlemen. So we got 2 times 1.602 second E negative 1, 9. Boom. Divide by 5 second. E, negative 14. I'm kidding, not negative 14. Positive 14. Boom. 6.408 times 10 to the negative 34th. Is that wrong, dude? Is that wrong?
No, it's not wrong.
Yeah, we're good.
I
thought I did
Write that down. Write that
Wait, is
down.
it negative 34th?
Yeah, it's negative 34. It's right there. It's right there. We got that answer.
Baby, and
Joules times second. Or stopping potential, right?
it's just joule times second. Joule times stopping potential might be, yeah, you're right.
Okay, all right, I got you.
So, H equals 6.4 times 10 negative 34 JS. And that, kids, number 2. Atta baby.
Atta baby.
Atta baby.
Great job, man. I like the cowboy hat on you. It looks good.
Hey, thanks, dude. Maybe I work to school every now and then. You never know.
On A days, physics?
Hey, who knows? It could be like my good luck charm, you know?
All right. On to C. Are y'all ready to dive in to letter C, part 3? Because I am. My water-resistant banana boat. I'm all good.
He's ready to
Let's
go,
go,
ladies and
baby.
gentlemen. He's ready to go.
Woo! All right. So what it says is, from the graph, determine the work function for the metal. Okay, so what we think is we got to use K max is equal to HF minus work function. All right, so here we go. I'll write that formula down. Equal to H, Planck's constant,
Yeah.
frequency, minus work function. All right. Since we're solving for work function, this is what work function is equal to, right here. Work function is equal to...
What's up, bro?
I got it. So, all right.
You good, man? You good?
Hey, I'm good.
He's good, ladies and gentlemen. Just a
It's
little...
all good, it's all good. All right. All right, so work function is equal to Planck's constant times F sub ot C. And where F sub ot C is, all right,
go
so
to the graph.
let's go to the
Let's
graph.
go to the
Come on to the graph. F sub ot C is right here. This one right here. F sub ot C, which is equal to 5 times 10 to the 14th. Okay? All right, so knowing that, it's going to be work function is equal to Planck's constant 6.626 times 10 to the negative 34, put that in parentheses, times F to the C,
Oh, you're going to use
F sub ot C.
6.4.
6.4?
That's the one we found in the previous one.
Okay, all right. So let's cross that out real quick. Go down here. All right. So this is going to equal to 6.4 times 10 to the negative what?
What are you...
My bad.
We're having some
6.4
difficulties.
times 10 to the negative 34. Okay. And that is all times 5 times 10 to the, what is it?
14.
14? Okay. Okay, so I need the calculator now.
All right, we're going to the calculator, ladies and gentlemen.
All right. It's kind of hard to see with these dark shade goggles. Parentheses, 6.4 second E to the negative 34, parentheses, times 5E 14th. That's going to be what, 3.2 times E to the negative 19. All right, so this is the answer right here. Work function is equal to 3.2 times 10 to the negative 19 joules. That right there, ladies and gentlemen,
So you find the work function
C.
at a kid.
that is the work function
Part C, ladies and
for
gentlemen.
this problem. Let's
You're-
dive into number D. It's going to start right here at 6, and it's going to have the same exact slope as the previous line. So it's going to be up 2 over 5.
Yeah.
Up 2 over 5. So it's going to go
Go to 11 and then up to.
11 here. Right there.
Yep, and then just
And
keep,
just keep going. Keep her going. So that's how it's going to be, and that's all for D. It's real simple. Just put the line on the graph.
And then, in the wise words of Drake in the game, Keep it 8 more than 92, 100. Yes, you will get a 100 if you listen to us and do exactly as we say. 8 more than 92, ladies and gentlemen, is 100. Tell it to him, Ryan.
8 what? How do you say that?
8 more than 92, bro.
8 more than 92 is 100. That's what you're going to get on this all or nothing quiz.
You're going to get 100.
Boom. That's it. Good luck, guys. Knock this quiz out. You can do it.
Hey,
Peace out from me and Caleb.
deuces. Later. Good luck. Y'all going to do great whenever you take this quiz. I know it's going to be money.